So in this vernier caliper, we are using several usage of this part of the vernier calipers. So the outer jaws are used for measure the diameter of the object. The inner jaws are using to measure the inner diameter of the tubes or any other object. Here, this capital R letter denoted the main scale divisions. This is the main scale division, and the small values denoted as a vernier scale. And also this G is a depth probe. This is the G is the depth probe. This is using for measuring the depth of objects. And this one L is lock, lever for locking vernier in place, right? This is one. This part is L. This is the lever for locking vernier in place. And the W is the knob for is for movement of vernier. So the main scale is in centimeters. So the vernier scale are moving on the main scale. So here, how to use this parts of the vernier caliper for measuring the length of objects. Here, this is the test tube. So first we are going to measuring the inner diameter of the test tube. We will set this inner jaws touch the test tube's walls, so like this. And if we want to measure the outside diameter of the test tube, we are put in the outside jaws, like between this outside jaws we are put the test tube like this. Okay, and also we can measure the length and thickness of the wooden meter scale, right? Wooden meter ruler or wooden box or glass box, something. Okay, so these are the correct ways to keep the object in the vernier caliper. This figure is the wooden box, keep in the inside between the two outside jaws, and another two figures are wrong way to keep the object between the outside jaws. Okay, so this is the correct way, these are the wrong ways. And also if we measure the inside diameter of this object, we are keep the object like this. Another two figures are wrong method to keep the object. So these are the practical and also here if we measure the depth of the object, and also this is the inner diameter of the splinter, this is the diameter of the splinter. These are the wrong ways to measure the depth, and this is the correct way of the keep the object in keep the diameter, sorry, keep the vernier caliper in the object. So in this in this vernier caliper, we have two scales. One of this main scale, another one is vernier scale. The vernier scale is freely moving on the main scale. So this is the main scale, this is the vernier scale. Right. So here we are going to how to measure the readings. So this is the main scale. Normally main scale in centimeters value. So this is centimeters. So this one is vernier scale. So this is main scale, this one is vernier scale. These two are outside yours, these two are inside yours. So first one, what is the meaning of least count? So what is the meaning of least count of vernier caliper? The meaning of least count is the smallest digit on the main scale divided by the total numbers on the vernier scale is called least count of vernier caliper. It is denoted by LC. So mathematically we can get this equation least count equal to. Here this is the main scale. So this main scale have the centimeters values or 0, 1 centimeter, 2 centimeter, 3 centimeter. So in the 0 to 1 centimeter, between this 0 to 1 centimeters, we have 10 small lines. So 10 small lines equal to 1 centimeter. So one division. So this one is called as a one main division. So one main division equal to here 1 over 10 centimeter. So here the small line, the value of this small line. So here this small gap, the value of this small gap or the value of small line 0.1 centimeter in main scale. So we know that 10 millimeter equal to 1 centimeter. So here 0.1 centimeter is equal to 1 millimeter. So here the least count equal to the smallest digit on the main scale. So the smallest digit on the main scale is equal to 1 millimeter. So 1 millimeter over total number of vernier scales. Here 0 to 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 lines here. So this one is vernier scale. So vernier scale have a 10 divisions. So 1 millimeter over total number of vernier scale is 10 divisions. So 1 millimeter over 10 equal to 0.1 millimeters. This is the least count of this vernier caliper for this first figure. We have another equation of vernier least count is another equation of least count. Least count equal to one main division minus 1 Vernier division. This is the another equation of least count. So this one is 1 main division. So we will put the scale. So 1 main division minus 1 Vernier division. So here, these 10 Vernier divisions are equal to. So here, between this 0 to 10, we have equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 Vernier scale equal to, right, 10 Vernier division equal to 9 main division. So 1 Vernier division equal to 9/10 main division. So here, the 1 main division have a value of 1 millimeter minus here 1 Vernier division equal to 9/10 main division. So 1 main division equal to 1 millimeter. So 9/10 equal to 9/10 millimeter. So finally we can get the value of the least count 10 minus 9/10. So 1/10. So this equation getting from this equation, right? So this equation getting from this step, okay? So normally we are using least count equal to 1 main scale over total number of Vernier divisions. This one is very easy to calculate the least count. So now we can see the second diagram, this one, second diagram. Here we have a total number of Vernier scale. You should consider the lines, not these values. Only you can see the lines. So here Vernier scale 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So in this Vernier scale, we have 20 Vernier scale. Total number of Vernier divisions is 20 Vernier divisions. And also the least value of the main division is here 1 millimeter. So least count of this diagram 1 millimeter over 20. So we can get the least count 1/20, that is equal to 0.05 millimeters. The unit of the value is millimeters. Here also millimeter. So in this second diagram, in Vernier caliper, they put on the values 0, 2, 4, 6, 8, 10. This is only they putting the values, but we consider the number of lines. Don't consider these values 0, 2, 4, 6, 5, 8, 10. We only consider the lines only, okay? One, so here 0 to total number of Vernier scale is Vernier divisions is 20 Vernier divisions. So you see that number of lines. Okay, one total number of lines is 20. So third diagram, we have the total number of Vernier divisions is 50. You are counting this small lines here. So total number of Vernier divisions is 50. Here, the minimum value of the main division is 1 millimeter. So 1 millimeter over 50, we have get the least count of this diagram is 0.02 millimeters. So do you understand this method? Oh,
Yes,
yeah.
sir.
Okay. Another example. Example 1. The vernier caliper consists of the main scale and the moving vernier in a metric vernier in the main scale is marked in the centimeters and the millimeters. The vernier is 9 millimeters along the divided into 10 divisions, each 0.9 millimeter long. Before taking the reading with the vernier caliper, the least count and the zero error have to be determined. So this one is very important step of this using this vernier caliper. So here, before taking a reading with a vernier caliper, the least count and the zero error, right? This is the very important of this zero error have to be determined. So this one is normally we can calculate the least count. Already we done it. Okay. Another one is another new matter is a zero error. So here, what is the meaning of zero error? Normally, we are using this vernier caliper. When we start the reading, make the reading of in this vernier caliper, first we are going to check the zero error. So you should first touch this two outer jaws and then check the vernier and main divisions. The vernier divisions and the main divisions here. Okay, here the zeroth lines, the both zeroth lines are coincide with each other. There is no zero error, but the outer jaws in touch uh, the zeros levels here, the main division 0 and the vernier division zeros like this, not coincide with each others. There is a reading here. So this one is main division 0, this one is vernier division 0. We have the small error. This is the small error value. So we are going to calculate the value. So this one is positive zero error. Positive zero error. And also this one is negative zero error. So when we using the vernier caliper without any objects and the outer jaws in touching each others, we should see the two zero lines, main division zeros and the vernier division zeros. If two zeros lines are coincide with each others, there is no zero error. But in here, in this figure, denote the positive zero error. So in this main division 0 here. This one is main division, main scale. This one is vernier scale. So the vernier scale 0 in right hand side of this main scale 0, right? This one main scale 0 line, vernier scale 0 line in right hand side of this main scale 0, that is positive 0 error. There is small value of value here. So this one 0, main 0, this one is vernier. So this gap is a positive 0 error. So we are going to measure that 0 errors. So how to measure that 0 error? We have the equation of the reading. Okay, this is the equation of the reading. Reading is equal to main scale reading plus vernier scale reading into least count. So this is the equation of the reading. Reading equal to main scale reading plus vernier scale reading into least count. So here positive 0 error equal to here main scale reading is, you should see the before this vernier 0 to before this line. So here main division reading is a 0 plus vernier scale reading. Vernier scale reading is coincide with main division line. So this one is coincide with main division line. So here 1, 2, 3, 4. So fourth vernier division coincide with main division. So 4 into least count is 0.1 millimeter. So here we have get the value of the positive 0 error is 0.4 millimeter. Another one is negative 0 error. When we use the vernier caliper in the outer jaws in touching each other, the main division, the vernier division 0 line in left hand side of this main division 0. So this one is vernier division 0, this one is main division 0. So we have the small error of this value. So the equation of the negative 0 error, easily we can calculate the negative 0 error. First, you see the number of lines. Here 10 vernier lines we have. Which line coincide with main scale? Here, which one coincide with main scale? I think this one. This line coincide with main scale. So 10 minus 8 into least count 0.1 millimeter. So the zero error, negative zero error is 0.2 millimeters. We are putting the minus because this minus value, minus sign is give the negative zero error. So this one is one method. Another method, we know the number line. In number line, the middle value of this number line, middle of the number of line, 0. So the right hand side of this 0, we have positive values, and the left hand side we have the negative values. So here 1, 2, 3, 4, 5, and also here we have the -1, -2. So now we have the this main scale 0 is the number line 0. So we have in this side we have the positive values, and we have this one is negative values. So the equation of the reading is equal to, here this one is Vernier division 0. So we have before the this Vernier division 0, before the reading of this main division. So here this one is +1, so this one is -1, this one is +1, here this one is -1. So the main scale reading is -1 millimeter plus 8th Vernier division coincide with main division, so 8 into least count 0.1 millimeter. So we have the negative zero error equal to negative zero error equal to -1 plus 0.8. So we have minus 0.2 millimeter. So finally we can get the negative zero error, value of the negative zero error. The 0.2 is the negative zero error. So finally we calculate the correct value of the reading. You should minus positive zero error, because in this time Vernier caliper should give the zero value, but here we have the small error value 0.4, and also here Vernier caliper should give the zero value, but here we have the minus 0.2. So this one is less than 0, this one is greater than 0. So the correct reading is 0, but in positive zero error give the positive value, negative zero error give the negative value. So we are correcting the correct values. We will get the reading and then minus the positive zero error, and then if we have the negative zero error, finally plus adding with the reading. So we have so many examples for the zero error. So we first we have the example, see the examples of these errors. So now see the first one, first figure. Here the main scale 0 and the vernier scale 0 coincide with each other in vernier caliper outer jaws in touching each other. So here no zero error. Then we put the object between the outer jaws, then get the reading. So here the reading of this diagram, here main scale reading is 1.2 centimeters here. So the before, right, before line. So here the 1.2 centimeters. So main scale reading plus vernier scale reading. Vernier scale reading equal to coincide with vernier scale coincide with main division and the least count. Here third line coincide with main division. So this 3 into least count of this vernier caliber is 0.01 centimeters. Those are here units of this reading is centimeters. So we putting on 1.2 centimeter plus 0.03 centimeters. So finally we can get the reading 1.23 centimeters. So here no zero error. So directly we can write the reading 1.23 centimeters. So now second, here this is the zero error. This zero error is positive zero error because we are using the vernier caliper when the outer jaws are touching each other, but the lines of zeroth lines not coincide with each others. So here the vernier zero line in right hand side of this main scale. So we have here positive zero error. So positive zero error equal to main scale reading is 0 plus third line is coincide with main division. So 3 into 0.01 centimeters. So the positive zero error is 0.03 centimeters. This second diagram is the reading diagram. When we keep the object between the outer jaws, we can get the reading. So here main division reading is 1.2 centimeters and sixth vernier scale coincide with main division. So 6 into least count is 0.01. So the reading is 1.26. So corrected reading is, we are going to subtract positive zero error. So we get the reading 1.26. We are going to minus positive zero error 0.03. Finally, we can get the value, corrected value 1.23 centimeters. Okay, here the last one is negative zero error because the vernier zeroth line in left hand side of this main division 0. So now we can calculate the negative zero error here. I think eighth line of this vernier division coincide with the main division. So 10 minus 0.0. So see, this one is 7th division. So the negative zero error is 10 minus 7, so 3. So 3 into least count is 0.01 centimeters. So This one is negative 0 error, so we put the minus and the 0.03 centimeters. Now, second diagram is the reading position. So here we can get directly the zeroth Vernier zeroth line is coincide with 1.2 centimeter main division. So we can directly write the reading of this stage. So 1.2 centimeter. So finally, we can, this one is negative 0 error. So finally, 1.2 minus 0.3. So minus into minus plus. So we that is, I say, directly we can add the value of this reading. Okay, this means minus into minus plus. So 1.2 plus 0.03. So finally we can get the value of the corrected reading is 1.23 centimeter. Okay, this meeting will end it in 1 minute. So you please reconnect.
Okay, sir.
Okay, another examples of this zero errors. So first figure is there is no zero error because the Vernier zeroth line and the main zeroth line coincide with each other. So there is no zero error. This one is reading stage. So here we can calculate the reading. The main scale